While it's tempting to respond to the input event inside of the event handler, it's generally considered bad practice to do that. Now, to get a better understanding of that, let's look at this representation of a frame over time. Our green boxes represent the update of individual items that exist, and the red boxes represent the rendering of those items. Now, let's say, for instance, the user hits their keyboard, which would move the player around. And let's say that our engine actually gets that callback right here. So our updating of the player in a specific position has already occurred, including physics engine processing and everything else. While our rendering will now be polling data for a new position in the environment. Now, what this particular instance can lead to is an interesting phenomena. This makes a disjoint correlation between our update loop and our render loop. We can actually be updating our environment with the player at this position, yet rendering with the player at this new position. Now, while this may seem minute in a 30 frames or 60 frames per second environment, things get a little kooky once you start factoring in networked physics, which hopefully we'll cover a little bit later. In practice, the events come out a little bit like this. So let's say we have a timeline of events that are going to be passed into our application, and a timeline that represents our update loop. Now, what occurs is that we're not really sure when the events are going to come to us from the browser. They can occur pretty much any time they want. Now, what happens is if we respond to them in turn, we're not going to have the ability for our update system, or rather our game code, to properly be able to react to them. So what we do is actually store the input event data inside of our input manager so that the update loop, or game code, can query it whenever it wants.